In this video, Porter will be used to produce a Cloud Native Application Bundle, or CNAB, from an existing set of Terraform configuration files. First, we'll review the Terraform configuration files in order to get a sense of what will be created as part of this bundle. Then, we'll use Porter to actually produce the bundle from that set of Terraform configuration files. Once the bundle is created, we can install it and publish it so that it can be shared by other users. First, let's take a look at the Terraform. From reviewing this quickly, it's pretty apparent that we're going to be creating some Azure resources. If we look in the main.tf file, you can see that we are indeed going to configure the Azure RM provider using a service principal as the authentication mechanism. We're also going to configure Terraform to use the Azure RM as a backend store. However, we're not providing any configuration information here. This means that when we run Terraform init, we'll need to provide however we'd like to authenticate to it. Next, you can see that we're going to create a Cosmos DB and an Event Hubs. We've also defined some outputs and variables. The variables correspond to things like the service principal that we'll need, and then other configuration information, like what database do we want to create inside of Cosmos DB. The outputs will provide us things like the Cosmos DB URI and connection strings and topic information for the Event Hubs that we can then later pass on to our application code. So with this Terraform in mind, how would we build this into a CNAB using Porter? The first thing to do would be to create a Porter skeleton YAML using the porter create command. I've already done that and populated it with the necessary information, so let's review that. So here is the Porter manifest, or porter.yaml. Porter is driven by this manifest, both at build time and at runtime. Porter itself has no knowledge of the underlying technologies like Azure or Terraform or Amazon. It relies on mixins to provide that functionality. This makes Porter very extensible in that mixins can be developed for almost any technology as long as they adhere to a pretty simple interface. The mixins have two real responsibilities. One, they're responsible for providing build time information. So things like the Terraform mixin will most likely rely on the Terraform CLI or tool when it runs. So the Terraform mixin will be responsible for telling Porter how to build a invocation image for the CNAB bundle that has that technology built into it. The same would be true for any other mixins like Helm or Kubernetes. Second, the mixins are responsible for translating the configuration that they're passed into the proper calls to the underlying technologies. So when we do something like a bundle install and we pass a certain number of parameters down, the Terraform mixin will be responsible for translating those into the proper TF invocations of like TF apply or TF delete. So that's the first section of the Porter manifest. The next one is the credentials and the parameters section. And inside of here, you can see credentials we've defined for environment variables we want to populate, and these are going to correspond to a service principal. Parameters has a lot of things defined inside of it. We won't cover all of them, but they roughly correspond to all of the variables that are defined inside of the TF file. Finally, we come to the three verbs: install, upgrade, and uninstall. These are going to correspond to the main actions inside of CNAB bundle. However, you can add additional ones here like status and define them, and they'll be generated into the CNAB so that tooling can handle them as appropriate. For each one of these steps, however, you can see that we also reference the mixin, so Azure, exec, and Terraform. This implies that there's going to be three steps that happen for each install action. So when install is run, first we're going to use the Azure mixin. Let's take a look at what that's going to do. From the description, we can see that it's going to create an Azure storage account that we can use with Terraform. We're going to use the Azure mixin to create something of type storage. We're going to configure it to use the resource group that's defined by the parameter storage RG, and then pass some additional parameters down like location, storage account name, container name. When this is done, we're going to grab an output from that called storage account key. This information will be used to configure the Azure RM backend for Terraform. There's a number of ways you can configure it, but in this case, we're going to provide a storage account and the access key so that Terraform can store things like the TF state file inside of that storage account. We're also going to create it in a resource group that's separate from the resource group that we've defined in the parameters for the rest of the infrastructure, just for safekeeping of information. Once this Azure step is completed, the exec mixin will be used to emit the storage account key for later use. Somebody will be able to grab that and then save it off to a secure storage location later. And then finally, we'll use Terraform to actually create our Cosmos DB and event hubs. You can see for the backend configuration, we're going to provide the storage account name and container name that were provided as parameters and used to create the storage account. We'll also use the storage account key that was generated as an output from that previous Azure step. And then finally, we'll pass the rest of the information down as variables, and this will be used to configure the Azure Resource Manager for the provisioning, along with the rest of the variables that were defined. And from that, we'll grab a couple of outputs, Cosmos DB URI and Event Hub's connection string. At this point, the bundle will be done, and we could either ship it as is, or we could extend it by defining either some more Terraform manifest that we put into that directory to do something like use Azure container instances to provision some containers that will use that information, or we could combine yet another technology like the Helm mixin, or use Kubernetes directly via the Kubernetes mixin to apply a series of manifests. We can take the same information that we've outputted here, the Cosmos DB URI and Event Hub's connection string, and pass those on to later steps, just like we've done with the storage account key from the previous Azure step. So let's see this in action. The first thing we'll do is run porter build. And what that'll first do is copy over all of the mixins that we're going to use. You can see in this case, it's the Azure mixin, the exec mixin, and the Terraform mixin. It also copies over the porter runtime, and that'll be baked into the starting point of the invocation image that we'll use. It also copies over dependencies. We haven't touched on dependencies here, but the CNAB spec and porter both have concepts of dependencies. We won't get into that in this video, but it'll allow you to do things like take this bundle, ship it with just the Terraform configuration information, and then allow other people to define subsequent bundles that depend on this bundle. After it's generated the Docker file, it'll write the Docker file out and start the invocation image build. I mentioned previously that the mixins are responsible for not only providing the functionality of the tool they're wrapping, like Terraform or Azure, they're also responsible for providing the build time aspects. So what is necessary to install Terraform? Let's review the Docker file really quickly to see what that looks like. So you can see here the exec mixin didn't add anything. The Azure mixin didn't as well. We just didn't have an output statement to say that. That's because both of them are purpose-built binaries that really just know how to use either the Go SDK for Azure to invoke Azure or to run shell commands inside of the Docker container. The Terraform mixin, however, needs to install Terraform. So in addition to the lines that are here that are common to all CNABs that are produced by Porter, invocation images that are produced by Porter, this one's also got some Terraform declarations. And you can see here that we're going to use Terraform version 0.11.11, and then we'll run some apt-get install commands and wget to fetch Terraform and then dump it into the container. Inside of the CNAB directory, we also have the bundle.json that's been written out into canonical JSON form. Not the easiest to read, but this is the file that will be used for publishing later, and it's going to drive all the tooling. So now we've built this invocation image. We have a Docker, we've built the bundle, we have the invocation image built that represents that. We can actually go ahead and install it. I have an Azure portal window here, and you can see that it's filtering on things containing the resource group named Porter. I'll refresh it, and we can see that there's nothing that's been created. So the first thing we need to do with this is clear this window out so we don't have all this extraneous text. But we're going to need to provide some credentials. So when we use Porter, we can do Porter credentials generate, and it's going to read this manifest from in this directory. It'll also read the bundle if you have another bundle, but since we have this local, we're going to use this to build out a credential set. The credential set is going to specify the sources of information that correspond to these destinations of information. Inside of the manifest and inside of the bundle.json, the credentials definitions really say where the information should go. When you run this command, you're saying where the information should come from. I already have environment variables set that represent my service principal, so I'm just going to use those right now. So for client ID, I'll use Azure client ID. For client secret, Azure client secret. For subscription ID, Azure subscription ID. And then for tenant ID, we'll do Azure tenant ID. Okay, so that generated us a credential at this location. So we can go ahead and install this bundle now. So we'll do porter install, and I don't actually need to specify this. Porter will guess it for me by default, but just for completeness, I'll specify it. So we're going to give that credential, And because we've provided defaults for all of these parameters, we don't actually need to provide anything now. I can just run the command. So we'll do that now. Porter install -c porter terraform example. When this runs, the first thing that we'll see is that we're going to create the Azure storage account for use with TF, and that corresponds directly to the description of this first step. It's starting deployment operations, which means that it's actually talking to the Azure Resource Manager, or ARM, to create the storage account. This will take a few moments, and once that's done, we'll move on to the next step, which should be emitting the storage account key for later use. So we see that that's finished, and it's finished creating the storage account. We've dumped out a base64 encoded version of the storage account key that we can save for later on usage. And now we're actually initializing Terraform, passing that information down, securely masking the sensitive information like the access key, and then moving on to actually creating the Azure resources. If I go up here to my window again and hit refresh, we can see now that we have a Porter storage account created, along with the Event Hub's namespace. At some point after this, the Cosmos DB should show up, and this will finish. Once it's finished, the bundle will be done. We can inspect the claim that goes along with it, and we can do other operations like upgrade and uninstall. We'll revisit this once this finishes. It'll take a few minutes, so we'll pause for now. So now that we see the bundle has finished, we can go back to our portal window and refresh really quickly, and we should see that there's also a Cosmos DB. So now we have a Porter storage account that's in the Porter storage resource group, along with a Porter Event Hub's namespace that should have a hub inside of it. Sure enough, there it is. And the Cosmos DB, which should have a database inside of it. If we look at the Data Explorer, sure enough, there's Porter Terraform. So this isn't super surprising. Terraform was used to create all of these things, and we had a working set of Terraform configurations before. What we really demonstrated, however, was that we could use Porter to build a bundle that can wrap all of that up with a minimal amount of effort. Porter itself doesn't know anything about Terraform, we mentioned that before, but it does know that it has a set of mixins available to it, one of them being Terraform. So with this concept, we can actually build tools to support pretty much any technology and extend Porter to support those things. Porter can be used to be a purpose-built tool. We could build just the Terraform bundle using Porter and the Terraform mixin, but I think the real power of Porter comes in when we mix things like use the Azure mixin with the Terraform mixin, or when we use the Terraform mixin with the Helm or Kubernetes mixin to run some workloads and pass information between these steps. It really frees us up from having to write a lot of domain-specific things that are really only relevant to CNAB. Things like writing the invocation image and figuring out how to build the Docker file itself. Porter took care of those things for us. Porter also takes care of publishing. So once we're happy with this bundle, and I think we can see that it does everything we need it to do. It installs the event hubs in the Cosmos DB, creates the storage account for us. We can go ahead and actually publish this thing. And we'll do that with the Porter publish command. And similar to build, it's going to go ahead and push it's going to take the invocation image and it's going to push that up. That doesn't happen during the build step, so it's not really similar, but it's going to take that invocation image that we've already built and retag it based off of what we have inside of our manifest. So some of the metadata we have here, invocation image, we've specified where we want to publish that invocation image to. So it's going to actually publish that up to my Docker Hub. It'll take a little bit of time because it's going over the network. But once that's finished, we're actually going to grab the registry reference, or the SHA that's associated with that, and we'll use that to regenerate the bundle.json and then publish the bundle.json also to Docker Hub using the CNAB to OCI library. So we can see it's finished publishing. Now we're regenerating that bundle.json. We've pushed that up, and we've also pushed up a version of the bundle. So Porter Terraform v1.0 also has a SHA associated with it.